It's Flashcards Fridays at Math Science History, the tiny time machine that fits right in your pocket. I'm Gabrielle Burchak, and today we are exploring something really nerdy and wonderful, the neuroscience of puzzles. Not just why puzzles are fun, but what your brain is actually doing the moment you lean over a crossword, a logic grid, or a deliciously tricky time travel cipher. But first, a quick word from my advertisers. Since my holiday puzzle dropped this last Tuesday, yes, the time-traveling two-parter filled with clues, riddles, and chrononaut chaos, I thought this would be a perfect callback to Tuesday's episode. Please be sure to go back and give it a listen and give it a go. See if you can win some of our merch or even that Amazon gift card. So today, I'm going to peel back the layers on how the brain solves puzzles and why you get that burst of satisfaction when you crack the answer and how you can literally train your brain to love doing puzzles even more. So get comfortable, grab your coffee. Yep, your coffee. Speaking of coffee, don't forget to click on that coffee button at mathsciencehistory.com and make a donation to the podcast because every dollar you spend keeps this podcast up and running. So get comfortable, get your coffee, and let's uncover the science behind one of humanity's favorite brain sports. So when you sit down with a puzzle, whether it's a logic mystery, a cipher, a Sudoku grid, or even my Tuesday time traveling challenge, your brain doesn't just flick one switch. It lights up an entire constellation in your head. Puzzle solving is a whole brain event, and several systems jump into action like a well-rehearsed ensemble. So let's walk through the starring cast. Right behind your forehead sits the prefrontal cortex, the executive control center. This region is responsible for planning, decision-making, rule-holding, and rational thought. Whenever you think, okay, if this clue goes here, then that one must go there, that is your prefrontal cortex doing the heavy lifting. Your prefrontal cortex is especially active during multi-step logic, comparing clues, forming hypotheses, testing those hypotheses, and discarding the wrong ones. This is the region that helps you stay organized in your thinking. It's also the part of the brain that scolds you when you try something illogical, and then it gently nudges you back on track. All right, now let's swing over to the parietal lobes. These handle spatial reasoning, pattern detection, and mathematical relationships. You know, that little mental leap you make when you suddenly recognize a repeating number pattern or see how two symbols relate. That's the parietal cortex's specialty. And one important part of this, the intraparietal sulcus, is especially bright during tasks involving numbers and quantities. So if your puzzle involves Fibonacci sequences, base 20 number systems, or cleverly disguised time conversions, you are engaging it directly. Okie dokie, heading over to the hippocampus. This is the brain's librarian, and it quietly organizes every reference you pull while solving a puzzle. It retrieves stored knowledge, compares new clues to old ones, and it helps you mentally catalog everything you've learned so far. So whenever you think, wait, didn't the earlier clue say something about that? That is your hippocampus handing you the right book at the right moment. Let's hear it for librarians of the brain. Now, on to the anterior cingulate cortex, the error checker. This one sits between the emotional and cognitive centers of your brain. It is the watchdog that raises its hand and says, something isn't quite right here. It detects conflict, it notices inconsistencies, it senses when you are so close to an answer, but you're not quite there. That little internal tension, that tug of war between possibilities, it is the ACC at work. And the moment you fix the error, it relaxes, rewarding you with a little neurochemical relief. This is the fun part. The dopamine system, especially the ventral stratum and the nucleus accumbens, is what gives you that unmistakable yes moment when you solve a puzzle. Dopamine is the neurotransmitter of motivation and reward. It surges when you achieve a goal, crack a clue, or hit that satisfying aha insight. It's the brain's way of saying, great job. Let's do that again. And again and again and again. That's my brain right there. Suddenly, puzzles aren't just mentally engaging, they are emotionally gratifying. And that's an understatement. Finally, the default mode network, your brain's daydreaming system. It turns on when your mind wanders, when you step away from the puzzle, or when you stop trying so hard. Many insights happen in this state. Have you ever solved something in the shower? I have. Or while pouring coffee? Yep. Or while staring out the window? Well, that's the default mode network connecting dots behind the scenes. So, when you solve a puzzle, your brain is firing on pieces of the brain, kind of like an over-caffeinated workout buff at the gym. There's logic and reasoning, memory, pattern detection, error detection, creative insight, and reward. It is one of the most complete cognitive workouts you can give yourself. And there's no gym membership required, no renewals, and no annoying phone calls when you don't renew your membership. I'm talking to you, LA Fitness. So now, how does dopamine shape puzzle love? Okay, so now that we know what the brain does when solving a puzzle, let's talk chemistry, specifically dopamine. Dopamine is not the pleasure molecule. It is the anticipation molecule, the molecule of motivation. It is what gets you excited about finding the answer, what keeps you coming back for more, and what teaches your brain that puzzles are worth the effort. So, puzzle solving follows a reliable dopamine cycle. First, curiosity. Your brain whispers, "This might be fun." Dopamine raises a little. Then, the challenge. You start working. You're anticipating the reward, but you haven't earned it yet. Dopamine dips slightly. Then there's the breakthrough. You solve the puzzle, or even one step of it. Your dopamine spikes. Then finally, there's reinforcement. That spike feels good and your brain remembers it. So the next time you see a puzzle, your brain is more motivated to jump in again. So the more times you run this cycle, the stronger the association becomes. Your brain learns that puzzles aren't chores, they are rewarding. And the best part, well, dopamine isn't tied to difficulty. It's tied to progress. That means that little wins count too. Even recognizing a pattern or eliminating one wrong answer creates a tiny chemical reward. And this is the secret behind why puzzles become habit forming. You are conditioning your brain to associate curiosity with gratification. That's so cool. So now here's the big question. Can you train your brain to love puzzles even more? Absolutely, and the science backs it up. Here are the most effective, evidence-based ways to cultivate a puzzle-loving brain. First, start with the right difficulty. Not too easy, not too hard. Psychologists call this the zone of proximal difficulty, the sweet spot where the puzzle is challenging enough to be interesting, but accessible enough to be solvable. This trains your brain to expect success, which keeps the dopamine cycle rolling. Second, keep the sessions short but frequent. The brain loves small challenges, predictable routines, frequent rewards. 15 minutes a few times a week is more effective than one long marathon session. Third, you don't need confetti cannons. Just a simple acknowledgement, like a yes or a check mark in a notebook, or a quick fist pump, or recognizing your progress. Tiny celebrations signal the brain. That felt good. Repeat this behavior. And then you repeat it and you continue to feel good. I love puzzles. Okay, fourth, mixing puzzle formats keep dopamine from habituating. So try logic grids, crosswords, math puzzles, ciphers, pattern games, and narrative puzzles like the Math Science History Tuesday puzzle that came out this last Tuesday. Please be sure to go back and give that one a listen. You still have time to solve the problem because it won't be answered until the end of next Tuesday. And you have time to get the answer in. The deadline for all the solutions is December 16th, so you have time. But back to my point. Vary the puzzles. It keeps your brain curious. Fifth, pair puzzles with something pleasant. And this is called behavioral bundling. So you pair the puzzle time with, say, a cup of coffee, a cozy blanket, or your favorite soundtrack. Your brain begins to associate puzzles with comfort and pleasure. 6, track your progress. Progress markers activate dopamine even before you start. Try keeping a little log of the puzzles that you solved, or the difficulty levels that you've completed, or your improvements over time. The brain loves visible growth. 7, keep it playful. When puzzles feel like play, not an obligation, your brain is far more willing to engage. Curiosity thrives in low-pressure environments. A playful attitude increases insight, lowers stress, and encourages creative leaps. And finally, number 8, stick with the routine. Puzzle-loving brains are trained through repetition. 3 or 4 short sessions a week is all it takes to build the reflex. Over time, you won't just enjoy puzzles, you will crave them. That familiar little spark of wanting to crack the next clue is your dopamine network cheering you on. And this little voice of mine is also here cheering you on. You can do it. You really can. So the next time you pick up a crossword or open a logic problem or step into a time machine narrative full of riddles and clues, remember this. Your brain is performing a remarkable symphony of reasoning, memory, creativity, and reward. Puzzle solving doesn't just sharpen your mind. It energizes it, it satisfies it, and with the right habits, you can train your brain to genuinely love the process. Thank you for listening to Flashcards Fridays, and until next time, carpe diem.